An apple a day keeps the doctor away. Don't eat those apples. How many of us have gone to the market to buy groceries and have seen two different basket sections for the same type of apple? One basket shows the sign organic and is sold for a higher price, while the other basket shows the sign apples but is sold for a lower price. Which one would we buy? Well, the practical answer would be the apple selling for a lower cost, right? Wrong. The apples at the lower cost are genetically mutated apples which can give harm to the body. How? Well, if you try for yourself, normally when an apple is bitten into, the exposed part of the apple naturally turns brownish. This natural browning is caused by an enzyme which causes and gives cells a brown tint when exposed to oxygen. There are many apple types in which after 15 to 18 days after being sliced, bruised, or bitten into, they still seem to look fresh. How does this work? Well, the company modifies the genetic makeup of the apple such as that the enzyme that causes the brown tint to the apple is completely destroyed. That way the apple stays fresh and has a longer shelf life. With no genes left to create the browning chemical, the apple does not turn brown after it's been cut, and may look fresh when it's actually decaying. There are many documents to prove this. People have been playing around with genes for quite some time now to create these apples, but can we play around with genes in our body to cure cancer? Sounds out of the blue, right? Apples were genetically modified to increase the shelf life. On the contrary, cancer modifies the genetic makeup of the body and decreases longevity. How can we identify the genetic makeup and modification in our body? Well, first of all, what is cancer? Cancer is the name given to a collection of related diseases. In all types of cancer, some of the body cells begin to divide without stopping and spread into surrounding tissues. Cancer can start almost anywhere in the human body, which is made up of millions and trillions of cells. Normally, human cells grow and divide to form new cells and take their place. When cancer develops, however, this orderly process breaks down. As cells become more and more abnormal, old or damaged cells survive when they're actually supposed to die, and new cells form when they're not needed. This is the theory behind cancer. Okay, let's get back to the point. How many of us have had a sore throat or a common cold before? I'm sure all of us have at some point. Well, we go to CVS or Walgreens and walk up to the cold and cough aisle and pick up a medication over the counter, but so does John Doe and Jane Doe. What happens when a cancer patient walks into the doctor's office? The doctor prescribes a medication based on the cancer type. But cancer is heterogeneous disease. John Doe or Jane Doe may have the same lung cancer, but both would be given the same medication since they have the same disease. How soon John and Jane recover depends on how well the medication responds to their respective bodies. But what if I can read their DNA and design a medicine that is specific to John or Jane's body? This is called personalized cancer therapy. Oncologists are working on reading each individual patient's DNA. DNA is like sentences in a book that make sense. For example, let's say this sentence: the big fat cat sat on the mat. That's a group of words that make sense in a sentence. But what if I told you, the sat mat on the cat the big? Now does that make any sense at all? No, right? The first sentence is perfectly normal, but the second sentence is what oncologists would call cancer. As I said, your DNA is like a book that has sentences that make sense. In cancer, your DNA is supposedly exposed to carcinogen, any substance or agent that tends to produce a cancer. All the words jumble up and become nonsensical when this happens. The question then is, how do we solve it? Well, it's called genome sequencing. When a patient walks into the clinic with cancer, you would sequence the patient's DNA. You would then identify which particular sentence does not make sense. In medical terms, this is called mutation. Once you identify the specific mutation in that patient, you would design a drug specific to the patient's mutation. By doing so, the drug would be specialized to only Jane Doe or John Doe, but not both. Cancer is heterogeneous, which means two people may have the same cancer but respond completely different to the same drug for the same cancer. Genome sequencing and personalized cancer therapy is most likely the future of cancer medicine. Reading a patient's DNA and designing a drug specific to that patient is a step closer to making cancer a history. Thank you for joining me today.